So, good morning to all of you. Today, we are going to cover a very important topic from first year electronics engineering, that is communication engineering. This topic comes under Unit 5 of Fundamental of Electronics Engineering, which is a common course for all first year students of BTech AKTU. In this video, I am going to cover the following topics, that is fundamentals of communication engineering, then the basics of signals and its various representations, electromagnetic spectrum, then elements of communication system and need of modulation and its typical applications. First of all, what is signal? Any physical quantity can be expressed in terms of signals. When we see anything, when we say anything, when we are listening, when we are seeing, when we are traveling, we are almost always encountered with different type of signals. So, signal is basically a physical quantity which is used to carry some form of information. And in electrical system, the signal can be in terms of voltage, current or charge. Now, we move towards the type of signal. Broadly, the signals are classified into analog and digital. All real world signals are of analog nature, that is continuous with respect to time. Like this. So, any signal which is continuous in time as well as amplitude is called as an analog signal. And as they have a range of values, so analog signals are difficult to analyze because it consists of a large range of values. But it generates an accurate output also. In order to store these signals, we require a lot of memory as well, because analog signals are continuous in time and these are generally denoted by sine wave, cosine wave, etc. Compared to analog signals, digital signals have only two voltage levels, that is 0 and 1. Or these type of signals are also called as on-off signaling. So, digital signals are easy to analyze, but these are discontinuous on time as well as amplitude. So, the word digital stands for discrete values, that is discrete in time as well as amplitude. And generally, digital means only two values, that is 1 and 0. Now, if we talk about accuracy, these are obviously less accurate because it requires only two voltage levels as compared to analog. But it's quite easy to analyze these signals because it requires only two voltage levels. Or we can also say that digital signals are on-off signals. Now, before moving towards further classification of signal, first of all, we have to understand what are signals. And in today's environment, we are almost encountered by different type of signals at each moment of our life. These signals are broadly distributed in frequency range spectrum. Electromagnetic spectrum can be defined as a range of frequencies, and these frequencies are divided into visible and non-visible spectrum. We can able to see the visible signals, but a lot of non-visible signals also exist in nature, which are very important to understand. So, the electromagnetic spectrum consists of a range of signals which is based on the energy of photon. Now, if we classify the spectrum, we can classify it based on the range of wavelength or the range of frequency. We can say that the radio waves have wavelength 10 to the power 3 meter, or 10 to the power 4 Hertz frequency. Microwave have wavelength 10 to the power minus 2 meter or 10 to the power 8 Hertz frequency. Similarly, infrared has wavelength 10 to the power minus 5 meter or 10 to the power 12 Hertz frequency. Similarly, visible spectrum is in the range of 10 to the power minus 6 meter. Or similarly, ultraviolet signal is in the range of 10 to the power 8 meter or in the frequency range of 10 to the power 15 Hertz. And similarly, gamma rays is in the range of 10 to the power minus 12 meters and X-ray in the range of 10 to the power minus 10 meters. Or we can say in the frequencies, gamma rays means 10 to the power 20 Hertz and X-ray means 10 to the power 18 Hertz. If we classify this spectrum in frequency range and wavelength range with respect to nomenclature and application, we start from the very lower frequency in the range of Hertz and move towards terahertz. From 30 to 300 Hertz, the spectrum is called as extremely low frequency and is used in power line communication. From 0.3 to 3 kilohertz, it is called as voice frequency, which we use to communicate, and it is used for face-to-face communication or intercom communication. 3 to 30 kilohertz is called as very low frequency and used for submarine communication. 30 to 300 kilohertz is called as low frequency and is used for marine communication. 0.3 to 3 megahertz is called as medium frequency and is used for AM broadcasting. For 3 to 30 megahertz, it is called as high frequency and used for landline telephony. 30 to 300 megahertz is called as very high frequency and used for FM broadcasting and TV. 0.3 to 3 gigahertz is used as called as ultra high frequency and used as TV and cellular telephony. 3 to 30 gigahertz is called as super high frequency and used by microwave and radar. 30 to 300 gigahertz extreme high frequency and used by satellite communication and radar. 0.3 to 3 terahertz. This range is not used till date and it is used for new explorations. 43 to 430 terahertz. It is infrared range and used by LED, laser and TV remote sensing. 430 to 750 terahertz is visible light and is used by optical communication. 750 to 3000 terahertz is the ultraviolet range and used for medical applications. And for greater than 3000 terahertz, X-rays, gamma rays and cosmic rays, and till date these are also used for medical applications. So this is the overall distribution of frequency range in electromagnetic spectrum. Now we move towards the classification of signal. Broadly, we have seen that the signals are divided into two types, analog and digital, which are further subclassified into 6 different types, that is continuous and discrete signal, deterministic and random signal, even and odd signal, periodic and aperiodic signals, energy and power signals, and real and imaginary signals. Starting from the very first signal, continuous and discrete. A signal which is continuous in time as well as amplitude is called as continuous signal. For example, sin t, cos omega t are continuous signals. And a signal which is discrete, that is discontinuous with respect to time, is called as discrete signal. So if we take the discrete sample of this signal and remove the other continuous values, then it becomes discrete. So if we have to convert a continuous signal to discrete signal, we simply need to break this signal on time axis. This process is called as sampling. Next is deterministic and random signal. A signal is said to be deterministic if there is no uncertainty with respect to time. That is, any signal whose mathematical model is defined is called as deterministic signal. Like a sine wave, we can find out the value of sine wave at any particular time, so it is a deterministic signal. Or if we write xt is equal to t, then we can find out this value of this function for any particular value of time, so it is a deterministic signal. And what is a non-deterministic signal? If there are a lot of uncertainty with respect to time, then it is called as non-deterministic. Non-deterministic signals are also called as random signals. That is, the mathematical model of these type of signals is not defined. And we can say that noise is a random signal because we cannot be able to predict noise for any particular time perfectly. We can use probabilistic model to find out the value of non-deterministic signals. Now, even and odd signal. A signal which is symmetrical across y-axis is called as even signal. Or we can say that if x of minus t is equal to xt, then it is an even signal. And if a signal is same in first and third quadrant, then it is called as odd signal. Or we can also say that if x of minus t is equal to minus xt, then it is an odd signal. For example, sine wave is equal in first and third quadrant, so it is an odd signal, whereas cosine wave is equal in first and second quadrant, that is symmetrical across y-axis, so it is called as even signal. And any general function can be expressed as a sum of even signal and odd signal. That is, any function can be written as even part plus odd part. We can easily find out the even and odd part separately by writing f of minus t is equal to f even of minus t plus f odd of minus t. And for even part, f of minus t is equal to even t, that is f even of t. And for odd, f of minus t is equal to minus of ft. Now, if we add those two equations, then odd part will be cancelled out and f even is equal to ft plus f of minus t divided by 2. And similarly, if we subtract these two equations, f odd part is equal to half of ft minus of f of minus t. So by using these small formulas, we can easily find out the even and odd part of any function. For example, if a given function is sin t plus cos t plus sin t cos t, and we have to find out the even part and odd part, then the even function is sin is odd, cos t, and for other two parts, sin of minus t is equal to sin t plus odd multiplied by even gives odd signal. Sin of minus t is minus sin t and cos of minus t is cos t, so the overall sign will be minus. So sin t plus sin t cos t is odd. So by this function, we can easily classify any signal into even and odd parts. Now moving towards periodic and aperiodic signals. Any signal which repeats itself after a fixed interval of time is called as periodic signal. That is, if xt plus capital T is equal to xt in time, continuous time, or if for discrete signal is small n plus capital N is equal to x of n, then it is periodic signal, where capital T is fundamental time period and 1 upon T is fundamental frequency. For example, sine wave and cosine wave are periodic signals because it repeats after a time period, whereas an exponential signal is an aperiodic signal because it never repeats itself after a particular point of time. So the given signal here is also periodic. It's basically a sine wave with time period as 1 complete cycle. Now what are energy and power signals? First of all, how to calculate energy and power. For any given signal xt, if we have to calculate the energy, then we square the value of signal and integrate it over entire time. So energy is calculated by integration of x square t dt over entire time. And if we have to calculate the power, then energy upon time is power. So the same formula is used, limit t tends to infinite, 1 upon 2t minus t say t x square t dt. So for any given signal, we can easily calculate the energy as well as power. Now, a signal can be energy signal or power signal or neither. If energy is finite and power is 0, it is called as energy signal. And if energy is infinite and power is finite, it is called as power signal. And if both the energy and power are finite or both are infinite, then the signal can be neither energy nor power. We can also say that all periodic signals are power signals and all aperiodic signals are energy signals. Now moving towards real and imaginary signals. A signal is said to be real if its conjugate value is equal to xt. If xt equal to x conjugate t, then the signal is said to be real. And if x conjugate t is equal to minus of xt, then it is imaginary signal. For example, if xt equal to 3, then x conjugate t is also equal to 3. That is, it is a real signal. And if xt equal to 3j, where j is complex operator, then x conjugate t is equal to minus 3j, which is equal to minus xt, and hence it is a imaginary signal. So for real signal, imaginary part is always 0, whereas for imaginary signal, real part is always 0. And a signal can be mix of real plus imaginary signal, that is. So these are the different type of signals. Now we move towards the elements of communication system. What do you mean by communication system? Communication system means a system to send and receive a signal. Communication means sending, receiving, and basically processing of information between two or more devices. A collection of devices which work together to establish a communication between sender and receiver is called as communication system. We have used various communication systems till date like radio, TV, mobile phone, landline, computer communication are all different types of communication systems. So any communication between one and other individual or one and other system is called as communication system. And if there is only one sender and one receiver, then it is called as point-to-point communication. And if there is one sender and multiple receivers, then it is called as broadcasting or broadcast communication. So we move towards the basic block diagram of communication system. It consists of information source, input transducer, then transmitter, communication channel, receiver, output transducer, and destination. Now starting from the first one, what is information source? Information is the real world message. It can be voice, it can be audio, it can be video, it can be picture or anything. So any message in terms of sound, light, picture, word, etc. is called as information. Such type of information is not possible to be treated by an electrical system. So a transducer is used, which is basically used to convert non-electrical signal from information source to electrical signal for further processing. This electrical signal is given to transmitter. Now what does transmitter do? Transmitter basically amplify and modulate the signal. Transmitter, the major important block within transmitter is modulator. What is modulator? As we can say that if we have to walk on foot, we can cover only a few kilometers. But if we have to move from one city to another city, we have to use either train, or if we have to move from one country to another country, we have to use high power medium, that is train. So in the same way, signal also requires some kind of medium to transmit. Means we have to increase the energy of that signal so that it can be transmitted to long distance. And for this purpose, modulator is used. Modulator basically convert a low frequency message signal to a high frequency signal. That is, superimpose a low frequency message to a high frequency carrier signal and send it to the destination. At the destination, the message is extracted from the carrier and the carrier is discarded. In the same way as when we reach our destination, we come out of the medium of transport, that is either train or plane. So in transmitter, the energy or power of the signal is increased and the signal is modulated using some technique, and then this high frequency modulated signal, high frequency high power signal, is transmitted through channel, wired or wireless, based on type of communication. For example, if we talk about landline communication, the channel will be wired, and if we talk about mobile communication, the channel will be wireless. Channel is the main source of noise in over this communication system. It's the open environment through which the signal travels, and through this channel, majorly noise is added to the system. Again, the channel generates an electrical signal which goes to the receiver. And receiver consists of amplifiers and demodulator. The work of these demodulator is just the reverse of modulator. Modulator converts low frequency message to high frequency signal, whereas demodulator extracts the message from high frequency received signal. So receiver consists of demodulator plus some amplifiers and filters to generate the output signal. This output signal is in electrical form and which needs to be again converted to the required form as per the information source. So we use an output transducer which converts electrical signal from receiver to non-electrical form suitable for destination. So this non-electrical signal can be voice for mobile, picture for TV and so on, and this signal is transmitted to the destination. So this is the overall architecture or block diagram of a communication system, which consists of information source, input transducer, transmitter, channel, receiver, output transducer and destination. And the noise by default adds to the channel, and hence treatment of noise is very important in receiver side. So we have already discussed what is an information source. Information source is basically the raw information in non-electrical form. It can be in the form of sound, picture, word, etc. This information, non-electrical information, is converted to electrical form by using a transducer called as input transducer. It basically converts non-electrical signal to electrical signal. For example, a microphone is a device which converts voice signal to electrical signal. It is an input transducer. Next is transmitter. Transmitter is a device which converts the signal, electrical signal from source to a suitable format for transmission through our channel. So it uses modulation to convert low frequency message to high frequency signal suitable for transmission, and modulation is the main function of transmitter, which we will study in detail in next lectures. So it increases the strength of signal, basically frequency, without changing the parameters of the original signal. And this signal is then transmitted through the channel. The channel can be wired or wireless based on the type of communication system. The channel is main source of noise, which is unwanted signal. And hence the treatment of noise is very important at the receiver side. So next is the receiver. Receiver is a device which receives the signal and convert it to the electrical signal in original form. So it consists of demodulator, which works in reverse process with respect to modulator, that is extract the electrical information from the received high frequency signal and then transmit it to the output transducer. Output transducer basically converts the electrical signal to non-electrical form suitable for destination. For example, loudspeaker is an example of output transducer which converts electrical signal to sound signal, and then this output signal is given to the destination, which is the final stage of communication. For example, if we are watching TV or communicating through mobile, then the destination and source person are humans. So now we move towards very important topic, that is modulation. It is the heart of communication system. In modulation, two signals are used. One is called as message signal or modulating signal, which is a low frequency signal, and other is called as carrier signal, which is high frequency signal. And modulation is basically to superimpose low frequency message signal on high frequency carrier signal. And in modulation, some parameters of carrier wave, that is amplitude, frequency or phase, is varied in accordance with the message signal, which is then transmitted by the transmitter. The receiver demodulates the received signal and get the message signal back from the modulated signal. That is, works in exactly opposite to modulation. And in the process of modulation, carrier wave actually act as a medium of transmission for low frequency information from transmitter end to receiver end. Different type of modulation exist are analog and digital, which are also called as continuous wave modulation and pulse modulation. Continuous wave modulation are of two types, amplitude modulation and angle modulation. And angle consists of two components, frequency and phase. So frequency modulation and phase modulation. Whereas pulse modulation consists of digital modulation and analog modulation. In digital modulation, the pulse code modulation and delta modulation, which are basically waveform coding techniques. And then analog modulation, PAM, PWM and PPM. Pulse amplitude modulation, pulse width modulation and pulse position modulation. So the first question is, what is the need of modulation? So modulation, as I've told, that it's very important to transmit a signal to longer distances. It basically increases the strength of signal by using a high frequency carrier wave and will not affect the parameter of the message signal. Modulation also reduces the size of antenna. With the help of modulation, it avoids the mixing of signal. It increases the range of communication, allows multiplexing of signals, and improves the quality of reception. As we know that the size of antenna is directly proportional to wavelength, that is lambda by 4, and wavelength is inversely proportional to frequency, that is C is equal to F lambda. So we can say that lambda is given as C by 4F. So with modulation, frequency increases, thereby height of antenna reduces. So which makes it feasible to design a communication system for a smaller height of antenna. Second, it avoids the mixing of signal. If we transmit the overall message signal in low frequency range from 0 to 20 kilohertz, the different messages may intermix, thereby generating crosstalk or error. So modulation is used, which converts each message signal to different high frequency signals, thereby avoiding the mixing of signals. It also increases the range of communication by increasing the frequency range. The modulation increases the range of communication also. Next, it also allows the multiplexing of signals. Multiplexing is basically to mix two or more signals over the same communication channel. This is only possible with modulation because it increases the frequency to a different frequency range, and hence different signals can be transmitted at the same time. It also increases the quality of reception because it reduces the frequency, and with frequency modulation and digital communication like PCM, the effect of noise is reduced to a great extent, thereby improving the quality of reception. So hope I am quite clear to all of you till this point, that is different types of signals, what is the communication system, then modulation technique, and why we use modulation techniques, that is need of modulation. So thank you all. In the next video, we will cover different modulation techniques. Thanks.